Yes.
Okay. I agree with Marcella. This is a different context than the Dubai's conference, and I wanted to try just to make like an introduction, a small introduction to this work, to understand maybe to understand the context behind this work that I wasn't able to do in Dubai.
Right.
First of all, I'm like not
It's much colder. It's much colder than Dubai.
yes.
Yes.
I'm okay.
Okay.
I'm not a very good English speaker, so I'm sorry for this. But I'm like a very simple person. I'm not like a real expert in any other kind of disabilities than motor disabilities. And I've always dedicated my research to people with hand impairments. This is because of my life experiences. I was exposed to people who cannot use their hands in order to to use their computer, and they were making like I don't know, they doing it with like not very efficient technologies and stuff. And this work here is stems from an idea to make an ecosystem of tools for people, of technologies for people with hand impairments, and I will describe it like in the presentation. And this was basically an experiment to try to put these technologies into practice. And I found that customization is very important in the field of accessibility. I was fortunately able to make to develop say a music technology for a child who lives in Portugal, and this was done because I was able to make a system from him like in 2 or 3 days, because this was the time that I had got to make it. And I try to stay with simple technologies. By simple technologies, I mean trying to extract value from technologies of everyday use. I mean laptops, um, webcams, and smartphones. I want to try to use this kind of tools and integrate this kind of tools into my instruments. And also, I stick with a very old-fashioned way of conceiving music. I'm a guitar player. I've been playing in various bands in my life, and I'm a son of my life experiences, of course. There's a happiness in being able to play together, and I don't know why. Maybe for me, instruments are like collective flow machines. We get in the flow together when we play, and we communicate in the meanwhile. We get lost in playing, and this for me is something that stems from played music with an instruments with skill based instruments, like I don't know, I mean like traditional instruments like guitars, pianos, and this kind of stuff. And they are like um, you continuously adapt to the instrument. The instrument tells you how it wants to be played. This kind of stuff for me are very like I fell in love with this kind of stuff during my life. And okay, uh, I will try to I will try to speak because I don't do it since a lot of time. So let's ditch the video. And Headbauer, this project here was made by me and by the revision of the thesis of a student, which is Pier Giorgio. And okay. Uh, as I said, I'm really in love with the psychological effects of playing music, um, and I think that music, in my life at least, was a mean to take part in a sense of community and participation. And one of my ideas was that there are people who are not able to use their hands to play and they're basically cut off from the world of music. And they probably have something to say. And I was wondering what will it tell us if they are able to express them, to express artistically. And of course, conventional instruments are mostly meant to be played with the hands. So people with, I'm sorry for this part because it's being cut off. People with quadriplegia, hand impairments, ALS in advanced stage have very few or no music performance possibilities since they cannot use their hands. Most of the instruments are meant to be played like this. And in the state of the art of hands-free instrument, we have many prototypes. Um, like maybe one of the most famous is the iHarp, which is a gaze-based instrument. I mean, you use an eye tracker, this guy here, in order to play it. An eye tracker, I think that many of us will be familiar with this, but I will tell it anyway. It's a device with infrared cameras which is able to detect the gaze, the position of the gaze on the screen. So I mean, I watched a particular point in the screen, and this device here is able to track it and to detect it. So I can use it to select buttons, yeah, this is the main purpose in many interaction uses of like gaze tracking. For example, the IARP, you have this interface with buttons with visual buttons on the screen, and you basically select using gaze. We have developed this guy here is was open source once upon a time. Now it's a paid product, and it has also it had also some limitation from my point of view because it used a lot of kind of filtering, which introduced audio delays and this kind of stuff, which are not that much acceptable in music playing in live performances. So I tried to develop new prototypes like Netitar, which again, the same principle, you select the notes by gazing to them, but with different layouts designed for gaze interaction.
Uh,
And
Nicola, may I
yes,
ask you one thing? You said that, of course, you work with a precise kind of disability, that is, people who cannot move hands, only the head.
quadriplegia.
Yes, but I met a lot of disabled people with the same problem who cannot even control head movements. So, do you have a kind of statistics or how many people are affected by quadriplegia, but who can exactly control head movement? Because all these applications require precise head movement, isn't it?
Well, actually, the IARP and Netitar are not meant to be played by head movements.
Hmm.
The head power, yes.
But yeah,
Yes, yes, yes.
of course. But if you have to control gaze, you have also to control head, or not?
Not actually, because
Not actually.
you can just move your eyes, and the eye tracker is able to detect it. You don't
But
have to move your
I
head
know a
to.
lot of people who has the head like this or like that, or not, who cannot keep the head straight.
Straight. Yeah.
Straight.
Yeah, of course. Well, I worked with this child here in Portugal, which I was mentioning before. He had like spastic head movements, but actually this device here, the version that he had of this device was able to keep track of the gaze anyway. So
Anyway,
it's like very robust towards like head movement
okay.
problems, and yeah. So, in the state of the art, many ways to play, many instruments which can be used to play melodies, chords, and we have also made one interface, one gaze-based instrument for DJing. But few of these like instrument these interfaces go after the note and chord selection or note intensity selection. So you basically don't have control over like a lot of other nuances of music performance, like timbre, envelope, and other expressivity parameters. So I wanted to try to make an interface which was able to put into the game other expressive possibilities and achieve more musical personality in the process. And so here it comes Headbauer. Headbauer is it's playable prototype. It's a playable instrument, but most of everything is a collection of interaction experiments. And the core concept, as Marcella wouldn't like probably, no, I agree. It's translating head movements into nuanced gestures of violin bowing. Um, I use a C sharp as a programming language and the Neat framework, which is this big framework that I was trying to make to enable the fast prototyping of new musical interfaces and stuff for people with hand impairments. It's basically a toolkit made of software libraries and do-it-yourself sensor devices, sensors that you can build by simple do-it-yourself practices, where when the sensors are not available in your laptop, if, for example, you want to detect breath pressure, you don't have a sensor in your laptop which is able to detect breath pressure. So I found like ways to make these sensors using simple tools like Arduino and small and cheap units that you can buy online. Like this is a just a correct name, low pressure sensor and low air pressure detector. And tubes that you can find in local do-it-yourself stores that you in Italy we call it brico. And this sensor here is actually it's like a blueprint of a breath sensor. You can make it for like 30, sorry, 30 euros or something like. And it includes also development and testing tools to make new sensor devices and to make them communicate through a common protocol. And this is many advantages when you have to like to modify instrument and to make them modular. I try to stick with open source and affordable and customizable solutions, and most of everything I try to make them as simple as possible, following the keep it simple, stupid philosophy, which is very common in computer science. The idea behind the Neat framework is to try to make a framework to easily detect uh, every kind of small movement that a person can make without with using stuff using that are from the neck upwards, so from the neck to the head, including gaze tracking. Eyebrow detection, gaze detection, voice detection, pitch detection, whistle detection, head movements, mouth aperture, teeth pressure, all that kind of movements that we can detect, and maybe a person that can also use independently. So I can move my head while I'm gazing, while I'm opening my mouth, and there are many possibilities actually in this field. And we are able of very nuanced movements using this uh, hmm, eyes, mouth, and these guys here. At Bauer, it's like um, let me call it a violin simulator, and I've used a very nuanced violin synth made by Audio Modeling, which provides us a very complicated but very useful and very beautiful plugin, which is Swarm. and Swarm can simulate by an acoustic model the bowing gesture and nuances like bow lift, so the pressure that we put on the bow. And the basics of head power is to use yaw rotation along the yaw axis to control bow sweep and intensity. Basically, I move my head like I'm moving the bow of a violin. And I use directional changes to trigger not on and not off events. So when I'm interrupting my head movement and going to the other direction, I can trigger new notes and to use roll and tilt along the roll axis and pitch to control various others parameters like vibrato, pitch bend, and brow pressure. For head tracking, head power uses like very, I don't know how to call it, available sources like webcam through another program which I've made, which is called come on, Neat Webcam Wrapper, which is able to detect head movements through the webcam. There's a small program, a small software, which is able to extract the head movement from the accelerometer of a smartphone, or using a do-it-yourself head tracker. This guy is basically the most precise. But if you don't have the resources to make this, you can use a smartphone, or you can use a webcam. This is the basic idea. And gaze tracking in headbauer controls no selection, real classic. And it's done through two kind of layouts. Headbauer contains this experiment with two layouts. You can use this. I made these two different layouts to as like experiment and the basic problem that you have to solve when you use gaze-based interfaces is called the Midas touch. The Midas touch means that if, for example, we have a basic interface like a piano keyboard, and we want to go from the C key to the A key, and we gaze using our eyes from the C key to the A key, even if the gaze movement is very fast, so the eyes do something like very fast like this, the eye tracker is fast enough to get the information, the gaze position, all in between. So you basically play not da, da, but da 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 da, something like this. You do the whole scale if you don't, even if you don't want to. So we have two layouts which solve this problem. One is based on like a direct emulation of a violin neck, and one it's called circular layout. And uh, let's see them in action. Then I will describe to you.
Violin. And we will see how Midas touch is minimized also in this layout.
Yeah.
And the other one is a circular layout.
Nope.
Using a
Sorry, wrong with the position. Okay, let's go.
And the other one is a circular layout using a novel design, which is particularly studied to minimize the Midas touch problem.
Okay, let's go.
So this is the headbauer in the violin layout configuration. And as you can see, I am playing it through a subtle yaw sweep motion. And I am controlling the vibrato with the mouth aperture.
Okay, so little description of what was happening here. We have this violin neck here, okay, and I was gazing at the various notes. and a new node happens when the selection of a new node happens when, of course, the gaze moved to a new key. For
Nicola,
example,
scusa,
yes.
concludi perché il tempo, dopo magari facciamo il dibattito dopo, se puoi concludere.
Okay.
Scusa.
Okay, I'm sorry. So I'll try to make it as simple as possible. And okay, hope I can shorten it. We have gaze selection for a new node, and we have like yeah, as you have probably seen, I have my head moving to control like not playing, and I was using my mouth to control vibrato, and I wasn't able to show you, but I had also had a phone application that was actually transferring data. I mean, I have my computer transferring data to my smartphone, and my smartphone was vibrating to have like haptic feedback for my playing. So the idea is, I don't know, to put this a smartphone, I don't know, placed on the head or on the neck of person or any sensitive area that the person has, and to recreate the some like also like touch information for the player. And maybe the last important information is that all of this is open source, so you can just I will send you the link. You can just use the follow the link and install it on your computer. Try to play it with your webcam, and with maybe even if you don't have an eye tracker, you can use the mouse just to try it. So okay, sorry for being long.
Ready? Okay, we have time then at the end to debate. And if somebody has questions, you can sign the questions and pose it at the end during the final part of the meeting.